Okay, 4.4 says, hence or otherwise calculate the sum of these two sigma notations. All working details must be shown. So over here on the first one, similar to the previous one, I expanded it. Here the first three terms. Along with the first three terms, I also included the last three terms. So this would be 5,000, this would be 4,099, 4,098. Then for the second part of it, which was the new pattern, should be a 1 over here, as is visible from this. So using this new rule, we substitute n with 1 and we get minus 3. Substitute n with 2, we get minus 5. With 3, we get minus 7. And then the last one gives us minus 9,999, 9,999. And we see a sort of similarity between a few of these numbers. Here from minus 5 all the way to the end here, we see that those numbers occur over here as well. It's just that the signs are opposite. So what we can see from these two is if we were to combine all these numbers, of course here we know there's a minus 9 as well, such as we can see over here there's a positive 9. It means that this pattern at the bottom is similar to the top, or it has a portion of it where it is similar to the top pattern. It's just that the signs are opposite. So what would happen is, if we were to take these parts that are similar but opposite in signs, they would cancel each other out. So all the terms here from the third up until 4,998, and here from the term number 2 up until the last term, all of them will just cancel out. When we add 5, we subtract 5. When we add 7, we subtract 7. Add 9, subtract 9. Add 9,999, we subtract the same amount. So honestly, the only figures here that are significant is the that would be minus 3 along with the last two terms here, because we see our pattern doesn't go this far. This is the last value of the pattern, meaning it will only be able to cancel out our values up until this point. And here there's a minus 3, but there is no positive 3 on this one here, so this minus 3 won't be cancelled. So that means if we were to sum up these two, everything but the minus 3 would cancel. Everything but the minus 3, the 1,000 or 10,001 and the 10,003, and this would sum up to 20,001. Now there is another method that you can use in order to solve these problems, which is usually the more conventional way, and it's a way that uses the formulas from expanding. So we know that there is the formula Sn is equals to n over 2, 2a plus n minus 1d. And this formula can be used for each of the two sequences that we have. So we have this first one and this second one, so these two series, and we can attain all the details that we need in order to solve for the problem, or solve and substitute into this formula. We have the difference here being 2, and we have the difference here minus 5 minus negative 3, that's negative 2. So we're subtracting 2 or negative 2 each and every time, and this will be it. So we know what the d is for the first one and the difference for the second one as well. Then we are able to use the sum of formula to directly find what the sum of each of these are going to be. Then we can add. So for the first one, we are summing up until the 5,000 term, or summing up to 5,000 terms, which means n is going to be 5,000 over 2. 2a is going to be the first term, which is 5, plus n minus 1. N is 5000 and our difference is 2. And then we get an answer from this. Then the second one, we're only summing up till the 4999th term, which means we replace n with 4999 over 2, and in brackets we have 2a, which is minus 3, plus 4999 minus 1 multiplied by negative 2 in this case. Here on top we get 25,020,000, like that. Then on the one at the bottom we get minus 24,999,999. Then if you are to add these two, which is basically what we are trying to get the sum of, you find that you will get 20,001, which is the same answer using that other method.